This time on Beat Up Builds, we get the transmission working on the 4Runner. Welcome back, everybody. My name's Daniel, and this time on Beat Up Builds, we hacked the A340 transmission. Give me a second, I'll explain. So I've adapted an M90 supercharger on my 22RE, and I have the A340 automatic transmission. When I adapted the supercharger on, I eventually went to standalone fuel injection. I'm running Microsquirt specifically, but that'll apply to other standalone fuel injections. And this will apply to some other scenarios. I think you can use this to control how long your gears are held. So like maybe if you change tires, you could use this on a stock ECU and everything, just intercept those signals and adjust them. So that way it holds your gears longer for bigger tires, things like that. It can kick down earlier if you needed to. So it could be really handy for that, and it could also be handy for engine swaps. Maybe if you're running standalone on an engine swap, or if you do like carbureted engine swap, this might work perfectly. Anything that'll connect to this A340, you can do this on. So the main thing is you need an older one like this 88 4Runner that has a standalone or a separate computer basically. So there's an ECU for the engine, and then this one is for the transmission. It needs to see a few signals from the engine computer, which we no longer have. So we're going to recreate those signals with an Arduino. I got two of these for like 25 bucks. These are really cheap. It fits Beat Up Builds perfectly. So let me take you upstairs to my studio. I have a great theory on how this will work. I'm going to bring you along for the ride. I don't know for certain this is going to work, but I have a good theory. I'm going to take you upstairs. I'm going to explain it. We're going to test it all on the bench. We're going to get your Arduino working up there, and then we're going to put it in the truck, take it out on the streets, and see if it works. So stay tuned. Nobody has done this before. I'm really excited to bring this to you. Let's go upstairs. Let's get into it. All right, so we're up here in the studio. Let me kind of explain what we're going to try and do here. So I looked in that factory service manual, and it gives some testing procedures. And basically it says like line 1, line 2, line 3, either need to be 0 or 5 volts. And I think that basically is like Morse code is probably the best explanation. Like it's either on or off, and then there's 3 different ones. So like maybe one's on, one's off, and that tells it what throttle position it's at. In the factory service manual, it does say at this, at this throttle position, it should see this. So I've kind of compiled a table of those values, and there's a few positions that I don't know for certain what the value should be. So I kind of guessed at that. For the moment, I took an educated guess. And I'm not going to show you that just yet in case we need to change something there. At the end, I'll show you my table. I'm going to share the code that I use for the Arduino and make it so that way, hopefully you don't have to do as much thinking as I'm doing, and you can just kind of plug and play what I've already thought up for you if you're in this situation and need something like this. So this is our Arduino. It came in this really nice package. I can't get it closed anymore because I opened it and touched things in here. But I got 2 of these for 20 bucks. It's actually packaged really nice, I have to say, for just a cheap Amazon thing. So we've got a cord for a 9 volt. I think I can snip this and hook it into the power of the car, even though it's 12. I'm gonna double check, but I think it resists down to 5 anyway. And I think it can do that if it sees 12 volts there. And this is gonna be our connection to the computer. You can also power it with this. And this is the Arduino basically in here. And then there's a little case I got to go with it. So that way it's not just hanging out there, bumping against things. I could mount it. Maybe I'll mount it to the case of the factory ECU that I patched into. We'll see. I'll have to figure that out. Let's get it working first though. So first things first, I'm going to identify what pins that I need. I've done a little bit of research, and there's some pins with like a tilde, that's that swoopy thing. Those can do
I think a variable voltage output. I think I'm going to use those to future-proof, because I'm pretty sure I'm going to need either just 0 or 5 to output, but by the chance, there could be a chance that I need to do values in between. So just to future-proof that, I'm just going to wire to those. That way, if I do have to make that change, it's just all in the coding and it's not actually in the wiring or anything like that. And then there's an input on here. I want to say it's like the A's over here can see a variable voltage. So that would be like your throttle position sensor. On the bench, I'm going to use a potentiometer, which will basically do the same thing. It'll vary the voltage. And then I have some LED lights that I'm going to wire up, and the lights are basically going to be showing me that L1 has 5 volts. Like if it's lit up, that's got 5 volts. Or L2 doesn't. So that way I can turn the voltage, watch what each one's doing, make sure it corresponds to my table, make sure it's switching quickly. I think it should switch pretty quick, but just double check that everything's going to work before I go and wire it up. And that'll make my life a lot easier. So I think I'm going to code first, and then I'm going to wire everything up. I have a potentiometer I'm going to wire up, and I have those lights. So let me grab those and do the code, and then I'll follow back up with you guys and show you what I have. I've started working on the code, and I'm focusing on the input right now. I'm trying to get the input working, and then after that's working, I'll go to the outputs. So I have a 6-volt battery, which I've used some resistors to make 5 volts, which will simulate our sensor voltage out of our TPS. And then this potentiometer right here is going to mimic the TPS. As you turn it, the voltage changes. And then right now I'm powering the board with USB right now, and also uploading the code. So I've got it to a point where I got the code in here, and down here it's giving me values. So right now it's at 0 volts, and as I turn my pot, the voltage will increase. So that's all working perfectly. And I can turn it back down. So I've got the input side of this all worked out. It'll be a lot cleaner once it's in the vehicle. There'll basically just be the one wire going to here. Just one wire, and then the ground's shared, so I think that'll be okay. I was a little bit stuck for a second because I didn't have the battery grounded to here, so the ground wasn't shared and it wasn't getting a good signal. So now it's working flawlessly. Let's see if we can get the outputs to work. We're making some big headway on the outputs. I was having trouble finding what I needed, so I posted on Reddit and asked about code. This guy helped me with the code right here. This guy's a legend. Thank you so much. So basically I put his code in, and then it wasn't working. I messed with it a little bit, and then somebody else recommended to use ChatGPT to troubleshoot code. I don't see their comment anymore, so I can't give them any credit, but I punched the code in ChatGPT. It showed me where all the errors were and what needed fixed, and I literally copy and pasted what ChatGPT fixed, and it works now. So I think I'm sleeping on ChatGPT. We need to utilize that more. So if we turn the pot, here's our little light. Comes on for a little bit, goes off for a little bit, comes on, and goes off. So that's the building blocks of what we need, and if we turn it back this way, it does the same thing in reverse. So that's the building blocks of what we need, and then basically this is what we need to punch in. So imagine the 5 is the LED lit up. So like I don't know, let's just pretend we did L1. So I need to do 3 of those, and I need to make this sequence match. And we also need to do it at a certain range, so that way, closed throttles, a little bit closed and a little bit off, and then right off throttles a little bit off, half. I don't think that's actually half. I just used half. Might even be a quarter. I might start out like a quarter throttle. And maybe wide open throttle is like half or something, or I don't know. I need to figure that out in my head, but I need to basically put these values in and then give a corresponding voltage for them to come on. And then that's kind of it. We just need to bench test it. Then we'll have 3 of these lights flickering, coming on and off, and that'll be our code basically. And then once that all matches our table and seems to be working right, we can take all of this and put it in the truck. I think I've got it, guys. So let me kind of try and show you what's going on. These are the states. So you see the 0s and 5s. So the first state, they're all 5 volts, which mean the light's on. So right now we're in our first state, and that's to ADC 103, which correlates to voltage. That's just what the Arduino uses. It's like bits or something. So that's going to go up to 103. So we're past 103 now. All the lights are out. So you can see the second one is 000, and that goes to 205. So let's go to ADC 205. Now we've got 1 and 3 lit. If we go to our chart here, 1 and 3 need to be lit, and that's till 511 ADC. So keep turning that. Right there, we're just past 511. So we have just L1's lit. If we reference our chart here, that's correct, and that goes to 718. And we're past 718, and we've got 2 and 3 lit, L2, L3, and that's what it corresponds to. And then it works going backwards. And if I go quick, it works pretty quickly. That's quick enough anyway. So I think we've done it. This little computer seems to be working. The code is relatively simple. Like there's a value, the ADC value is in there, and then you do true or false. So if we wanted to adjust this, there's one of these for each line. You just have to mess around with basically you just have to mess around with the ADC values to change everything. So it should be relatively simple to adjust and modify. And I was thinking it might also work for a stock 22RE. So like if you put bigger tires on a like stock 22RE automatic, you really want the shift points to like shifts to hold a little longer. So you could potentially use it to do this as well. That would be pretty cool. So I think we're basically ready to put it in. I have a couple things coming. I have a USB thingy for the car coming, like a hard wires to the car, and then it outputs USB. I think it's for like a GPS system. So that's coming in a day or two, and that'll give it power, and it also filters it, because if you were to just put from what I was reading anyway, if we were just to like put 12 volts into here through one of these things, it's going to be really dirty because the car's voltage is all over the place. If you have a voltmeter, you can see it kind of going up and down as you rev it and stuff, and it's just not good for this. So the USB thing basically will filter it real nice, or at least it should, which will keep the readings from getting screwed up. And that'll get us power, and then we just have to wire into the transmission, and then it also have the ground will be shared then too. So everything should work out perfectly. In the meantime, I'm gonna sit here and play around with it because it's fun. And yeah, I'll see you in the garage when we're installing this. So I'm testing the Arduino now. It's all wired in very, very temporarily just to see what's going on, what's happening. I tried to power it off of this cigarette lighter USB here, and the signal was not clean. My lights were flickering and stuff. It just wasn't working right. I don't know if that's because it's a crappy USB thing or if the cigarette lighter isn't seeing enough voltage. Could be either of those or a combination. What I have right now is it's for like a GPS thing that's wired right to the battery right now, and it puts out a USB. And that's giving me a nice clean signal, it seems like. And I'll mount it somewhere under the dash, but I'll make sure I get a nice, I run it straight from the battery. I'll use a fuse and everything. You also need to ground the Arduino to the battery, so make sure you do that as well. So the next part is going to be, let's make sure the inputs work. So I got the lights hooked up, and I'm going to toggle the throttle position sensor and make sure those lights are working the same way they did on the bench. I'm testing the input right now from the throttle position sensor just to make sure that's all working correctly. I'm getting a clean signal and everything. I've got it working right now. So all the lights are working correctly. They work pretty quickly if you need them to. So that all looks good. I just got to get it wired temporarily enough to drive it and see what happens now. Alright, I pulled into a parking lot. I'm going to plug it in and we're going to see what it does. Okay, see a green light. I feel like our connections are in here. Let's just drive around the parking lot. I don't know if this is a big enough parking lot to really get a good test. Let's go out on the street. Oh, it shifted. It shifted. Oh my God, is it working? Holding the gears pretty long. So it shifted third. It held the gears longer, it shifted third. Let's see if we kick it down. It should kick down, I think. Oh, it kicked down! Yes! Yes, we did it! It worked! This is freaking awesome! Oh my God! Now we just gotta play with some of those values. I might want it to shift a little quicker instead of hold it so long. But this is amazing. It downshifts. It drives fine now. This is a first. Nobody's ever done this before. I can't believe that worked first try. Awesome! I'm gonna try clicking it out of power mode and see if that makes it shift any differently. I don't know, it might be hard to tell right now, we're going so fast. It seems like it's holding the gear pretty well. And if I give it a little more beans, yeah, it kicks down. So it might actually be nice where the power mode might be good for like towing and stuff, like how it's supposed to be. I'll have to drive it around a little bit more, but this is amazing. I'm so happy.
This made my day. Alright, I'm gonna pull out of here and drive like a normal human being. I might do a little drive around. I'm actually really stoked about this. Alright, let's pull out like a normal person would. See how it shifts. So first, it's holding it. Shift set, that was really good. Shifted second, nice. And then it's holding second a little long, although it may need to at the tire size I have. I'm gonna make a right up here. I'm not gonna go right back home since this is working. I do need to finalize everything. It's just laying on the seat next to me. So there's still more to do. This is actually really nice. We're going up a hill, and I'm in drive, and it's going up the hill normal. Wow, that is awesome. I am so happy right now. This made my year, I think. This is almost as good as putting the supercharger on, figuring out this problem. I'm finalizing my installation here. I have these little pin things that go into the header here, and then I took some hot glue and I hot glued them in there so that way they won't come out, because they kind of just slide in there, those pins. So the hot glue is just a safety measure here. So let's do the final install on the vehicle and complete the project. I've got my Arduino permanently installed. I did have to add a capacitor for when the electric fan kicks on. It makes the voltage kind of surge, and the capacitor helps smooth it out. I also have connected the USB power supply thing to the battery, directly to the battery. That helps with those voltage fluctuations. The Arduino wants a really clean voltage. So I did that, ran those inside with a fuse, of course. And this is the hacked up ECU that I used to kind of make like a plug-and-play Microsquirt harness. And I also have my Arduino wires coming out of there. They run alongside the harness for the Microsquirt. It runs up under here and then goes under the dash, or the center console. And then around here. There you go. Comes out the other side. If we ever get carpet, that'll hide that nicely. I might zip tie it up a little bit. Haven't gotten that far. And I drilled a hole, put a grommet in the center console, and I mounted it in the center console with some stick-on Velcro. It was like, I don't know, 95 degrees today, and I parked in the sun all day, and it's still on there. So I think that's some good adhesive, and that's going to last a while. I'll probably put well, I want to put a plastic partition there that I can just slide in and out. And then I can still use this part of the center console. To be perfectly honest, I just had junk in there pretty much, just spare bolts and things. So I don't think I'm gonna miss out on that little bit of space in there, to be honest with you. But then when you close this, it's all hidden and everything. And yeah, I drove it to work today. Alright guys, today I took the truck to work. Also got a haircut, long overdue. And it worked pretty good. I didn't have any issues. Before, I had issues with the when the fan kicked on, the Arduino wasn't working correctly, so the capacitor has fixed that and also going directly to the battery. So that's better. It's like a 30-minute drive there and back, so it was a really good test to really get a feel for what was going on and how it was working. I think that there was 2 values on my table that I need to switch, I think. I kind of just guessed on where they should go. So I think basically almost its maximum range, that value, like right before the maximum, that value is, it's thinking it's like the throttle's closed most of the way. And then right off of idle, it's thinking throttle's open quite a bit. So I think I just need to flip those. That's the next thing I'm gonna do. And then I think we're done after that. So let me try that, and then we're gonna wrap this whole thing up. All right guys, I'm back from my drive. It worked great.
switching those values so I can share my table with you now. Everything's working correctly. It's 98 degrees in the garage, so we're up here in the studio filming this wrap-up video because it's a lot more comfortable here. So one thing I want to mention is there's 2 transmission computers. So I'm using the Denso one, that's what came in my truck. That gives the 0 or 5 volt signal to the L1, L2, L3, which go to the transmission computer, or they receive that. So there is also an ASIN one, and it's the same thing, it's just 0 or 12 volts. So if you have that, you can still do this, you just need to use relays. So they make breakout boards with relays on them for 12 volts for the Arduino. So if you purchase one of those, I think it might sandwich on top of each other or something, and that'll get it working just the same. It's just a little bit more wiring. If you know anything about automotive wiring, you know what a relay is, you know how they work. If not, Google it. They're pretty simple. That's one thing I want to mention. I already mentioned this, but I'm going to just touch on it again because I want to be super informative, so this can be repeated by somebody else that wants to do this. You need a clean power source. That's really important with these Arduinos. I learned that pretty quickly. So make sure you connect I used a 12 volt to a USB power supply. Mine was intended for like a GPS or something like that. Use that helps clean up the signal. And then I also had to put a 1000 microfarad capacitor. I think mine's rated up to 20 volts or something like that. They're pretty common to find. I would just use that one. And it says 1000 and it looks like a UF after it. That means microfarad. So just hop on Amazon. I got a big box of different capacitors because I'm sure I'll do other projects, and it was cheap. So that's really cheap. Really, this whole project was extremely cheap. I want to say maybe $50 invested, and I have another Arduino. I have a whole bunch of capacitors, resistors, jumpers or whatever to prototype something else or whatever, make something else. So it's a really cheap project. Anybody could afford to do this. The other thing I want to mention is there's also Arduinos that have Wi-Fi capabilities. It probably would have been helpful to have one of those. I didn't really do a lot of research, so I probably would have got the breakout board with the screw terminals. They sell those, and I would have got the Wi-Fi Arduino, I think, because it would have been easier to upload code, and it would have been easier. I think you can also look at the input values and stuff in relatively real time or close to real time. So that would have been helpful also to see what it's doing and what values. It would have made it a little bit easier. I had to guess a little bit, like I wasn't sure if my values were switched, but I already kind of had a hunch that they could have possibly been switched, and then I drove it and kind of guessed that. It would have been nice to just be able to see that real time, that data, and go, oh look, it's doing this. We know. So I'd probably get the Wi-Fi one if it's not much more money. It would be worthwhile. So now I can share my table, basically, of my values. So I'm going to put that up now. And while I'm showing you that, I'm going to mention you might need to adjust these values depending upon your tire size, weight, gear ratio, all that good stuff. It's pretty easy to adjust. It's pretty simple. Just play with the numbers. What I would recommend, save my file or my code or whatever, save that, and then save another one where you edit it and just play around with it and just mess with it till you get the result you want. It's pretty simple. The other thing I want to mention is the hysteresis. Basically what that does is keeps it from changing states until it's seen a certain amount of change. So it keeps it from like surging from different, like if it's in different states, it might be like locked and unlocked, like surging back and forth, like converter searching back and forth. So the hysteresis controls that. I think it's like 10 or 20 right now. Maybe go up by 10s, something like that, like 5 or 10, until it's not doing any surging or anything. Ideally, you probably want like the lowest value you can get away with and not have surging. 20 seemed, or what the 10 or 20 it's at seemed okay, but I don't know, I want to say I have under 2 hours of drive time, so I just maybe haven't experienced it yet. So play with those values. If you save a copy of the code, don't be afraid to mess around with it. And then you can also use, like I use ChatGPT, and that actually helped me. So you might be able to use that if you're having issues, or if you alter something, it might be able to like check the code for you. The other thing that I want to mention is I'm going to put a link to the code one way or another. But what I'm going to do right now is I'm going to put that code up just in case we're 10 years down the road and that link's not working anymore or something. I want everything to be in the video so anybody can do this. I really want anybody to be able to do this. And that's it. That's the whole video. I had a lot of fun doing this. I loved figuring out the problem and everything and coming up with a solution. I'm really excited that it was cheap. That's my favorite thing here, is to do something cheap. And we did it. I bought all this. I have lots of extra stuff, and I probably spent like $50 total. So anybody can afford to do this. It'll work for like my situation where I did a standalone fuel injection. I think you could use it on the stock computer and just like intercept that signal, like cut those wires and run a new signal into it. I don't see why that wouldn't work. You might be able to use this if you do I don't know, let's say you bolt a carbureted engine to the A340 and then you put a throttle position sensor on the carburetor in some fashion. All this stuff could potentially still apply. You just need a throttle position input, and then you need a switch for the IDL circuit is really the main thing. So you could rig something up with a carburetor, I feel, and then you could have your A340 working the same as it did with like the FI. So I think this is gonna be really useful. I would love to see people do this. I know everybody loves the manual transmission, but not all of us are blessed with that. And I don't know, I haven't found a manual transmission for cheap, so to spend $50 and make my automatic transmission work, that's a no-brainer to me. I'm just gonna hold on to it until I can, I don't know, find a cheap manual or whatever. Maybe it'll stay automatic a long time, we'll see. But hopefully this helps somebody out. Leave comments if you have questions, if you do this yourself, maybe you figure out new features you could add to this. Like, I'm envisioning you could potentially also have the map sensor control the table. Maybe there's 2 or 3 tables that are controlled with a map sensor as well to switch different tables for sooner kickdowns and things like that. Maybe that's something someone does. My goal was just get the transmission working again, and that's what it's doing. It seems to be working quite well, and it's been a great success. So stay tuned for my next video. I have all sorts of things planned. We got to work on the Dart. We got to get that supercharger on there. I probably need to, I feel like I need to work a little bit more on maybe the ignition system on my truck, and then we'll eventually go to ethanol and stuff like that. So I got tons of videos that I'm going to come out with. Subscribe, and I'll see you next time.